Welcome back to the GCSE Maths Pro YouTube channel. Today's video is the third and final part of the vectors topic, where we'll be looking at questions that involve ratio and scale. Let's start off with a slightly nicer question. So we've got A, B and C are 3 points such that the vector AB is 1.5a plus 4b, and the vector BC is minus 6a minus 16b. We are asked to find the ratio of AC to AB. So this is quite a niche question. So I'm going to actually draw out the vectors, obviously just roughly, so that I can kind of visualize it. So let's use this line here, but let's actually have a look at some of these vectors. So first of all, the thing that we can note is, if you checked out the previous video, you'll recognize that we've actually got two parallel vectors, as in we've got the same scale factor. So here is obviously multiplied by minus 4. And for the B ones, exactly the same. It's multiplied by minus 4. It's the same scale factor, which means they are parallel. So what we can say is that all three of these points do lie on a single line. The next thing to realise, though, is that you might naturally think that A, B and C will go in that order. So like, for example, A here, B somewhere here, and C over here. But in this case, something to note is that the B to C vector is a negative. Now, when we're working with vectors, negatives mean we're going the opposite direction. So if you think about it, let's say AB is just the positive direction, let's say is that way. To go from A to B, we go that way. But then to go from B to C, we're actually going the opposite direction, aren't we? So back this way. So if I were to roughly draw this out, I would say, obviously we can see that AB is a lot shorter than BC. So let's say we put A somewhere here. Again, it doesn't have to be accurate, just so you get an idea. B can be here, and then C is actually back here. Because A to B is that direction, and then B to C is actually the opposite direction, isn't it? And longer. So that's our line there with these two vectors. Now we can have a look at finding the ratio of AC to AB. So the ratio is in terms of just the length, right? So we just obviously want two numbers for the length. So we know that this part here is 1.5a plus 4b, this part here. And then B to C was minus 6a minus 16b. So as we looked at before, we found the scale, right? It was times by minus 4. Now obviously negative in terms of a distance, in terms of a length, is irrelevant. So we know that B to C is 4 times the length of AB. So B to C as a vector is 4 lots of AB, if we just purely think about the length. If this is 4 lots of AB, then we can assume that there are obviously then going to be 3 lots of AB that would fit into the rest of it, wouldn't it? So you make up 4. So looking at my ratio, I want the ratio of AC to AB. So let's say, because AB is the smaller bit, isn't it? AB can be 1. And then how many lots of AC do we have? Well, there's 3. So we've got 3 to 1 for the ratio. Okay, so now getting on to some more vectors geometry style ones where they've actually drawn a shape for us. So here we've got ABCD is a parallelogram. M is the midpoint of BD. As you can see, it's not been drawn, so we might want to draw that on. So we want to first draw the line BD there, and then M is exactly in the middle. ADE is a straight line such that AD to DE is K to 1. Now, you might be thinking that, where's E? Again, they haven't drawn it on. So what we're going to want to do is extend the AD line because it goes in this order, ADE. So if we just extend the line like that, E is somewhere over here, isn't it? Okay, then they've given us actual vectors. So the vector AB can be written as lowercase a. And again, direction is super important for vectors, so that's pointing that way. AD is B. And then the question is, given that the vector ME is 5b minus 0.5a, find the value of k. So k was our ratio here. So this one's going to be a lot of drawing. I'm also going to draw a line for the vector ME, just so we can visualize it. That one is 5b minus 0.5a. Okay, let's say if we were to find ME, and we couldn't obviously walk down it, because let's say we didn't know the actual vector for ME, we would have to find other routes that would help us get there. So we can use the A and the B, those are the only vectors that we actually know that are defined, but also the information that this is a parallelogram. If you've seen other parallelogram questions, you'll know that parallel vectors are the same, but maybe one's a bigger version of the other, they're multiples. Obviously, in terms of a parallelogram, we know that the sides are the same length. So for example, DC would also be the same as A, and BC would be the same as B. So we can label that as well. There are many ways to do this question. I would say we want to know BD, because M is the midpoint of that, isn't it? We're going to have to travel down one of these lines. So let's work out BD. So starting at B, how do I get to D? Well, either way, I can go along and up, or I can go up and along, doesn't really matter. So we've got B and then minus A, because I'm going the opposite direction, which means I need to put a negative. Now M is the midpoint. If I want to go from M to E, I might go M to D and then D to E. So MD is just exactly half of BD, isn't it? Same direction, just half the size. And then I know that I would have to add DE, which I currently don't know. It's on a straight line, so we know it's going to be some kind of multiple of B, isn't it? We don't know how long it is, that's what we're trying to find out, but we know it's a multiple of B. So let's say for the vector ME that I'm trying to create, I know that I've got a half B minus A plus, because we're going in the correct direction, whatever DE is. And that's the vector I want to know, isn't it? Now, do you see how I could compare that to the actual vector they've given me? We know specifically that it is 5b minus a half a. Let's compare that. So let's expand these brackets. I'm going to use 0.5 just so it matches the other vector we've got. So we've got 0.5b minus 0.5a plus whatever DE is, which we know is going to be some multiple of b, isn't it? Because it's parallel to AD, is the same thing as 5b minus 0.5a. So have a look. We can compare the minus 0.5a's, those are the same, and then 0.5b plus DE. Do you see how that must equal to the 5b? So you can you don't even really need to write it down, but just to show you, you can write an equation. DE plus 0.5b, which was on the left side, is equal to 5b, so therefore DE must equal to, if you think about algebra, 4.5b. So we've worked out DE. Now we just need to make sure we've got it in the right ratio. So they've said AD to DE. So let's write that. AD to DE. Well, we know that AD is 1b, so just 1. And then we know that DE is 4.5, so that's there. Now the only other thing to note is that they do actually want it in the format where DE is 1. So we just have to convert it, which I'm going to leave as a fraction because it's recurring, is 2 over 9. So K is 2 over 9. And there's our answer. The next two questions are very similar to each other in terms of the method we're going to use. Now, vectors is one of the hardest topics, I think, on GCSE Maths. So my advice for it, if it doesn't really make a lot of sense to you, is first of all, make sure you obviously master column vectors. That's video number 1, part number 1, because that was the easiest bit. The second video, which is on parallel vectors, is fairly straightforward, so try and learn that one. In the case of the next two questions, you have two options. Either your tactic is going to be that you have a look at it, you recognise it's one of these harder questions, and you just spend a couple of minutes writing down any vectors you can figure out. Doesn't matter if you think they're relevant, just have a look around whatever shape they gave you and write down any vectors you can work out, and then move on. Don't worry about what the question is actually asking. Hopefully with that you'll get at least 2 marks. Or you have a look at the method that I'm going to use for the next two questions, see the similarities and start to work out the pattern, so that if you do get a question similar to this again, you might remember roughly the method that was used. But it is quite complex. So if you watch this next question and you're like, I have absolutely no idea what you're talking about, I would recommend that you just stick to the option 1. If you see a vector question, just write down as many vectors as you can figure out and then move on. There's no point wasting time in an exam if you're not convinced that you know even where you're going with the question. Specifically, I mean in terms of vectors. So that's my advice. Now I'm going to go through the next two questions and then you can pick out what you want to and leave behind whatever you want to. So ACD is a straight line such that AC is equal to a third of CD. So AC is a third of the top part. M is the midpoint of AB. And then we've got some vectors which I'll write on. So AC is A, AB is B, and then we've got here that Cn is equal to K times CB, where K is a scalar quantity. Given that MND is a straight line, find the value of K. So this is quite a key thing, is if you're given something like this where they ask you to either find a value of k or find a ratio, and they mention something about, given that this other thing is a straight line that seems completely irrelevant, that's the type of question that has this answer. So normally these are about 4 or 5 marks, but the amount of working we're going to do does feel like a lot more than that, and it might even take you a lot more than 4 or 5 minutes in the exam, which again is why you might decide it's not worth it. But that's a personal choice, only you will know what to do in that case. So when they've mentioned specifically that you've got a straight line, which is normally not necessarily drawn on, you can see they haven't connected it here, we are going to want to find 2 vectors from that line. So what I mean by that is you could choose to find MD, you could choose to find MN, or ND. As long as you've got 2, it doesn't matter which. Normally I choose the whole line, as in this case it would be M to D, that's like the whole thing, isn't it? And then one of the smaller ones. So let's work out the vector MD. So we're starting at M. What route can I take to get to D? Well, I could go along to A and then up to D. Currently I don't know CD, so let's work that out based on the information they gave us here. AC is a third of CD. So if AC is A, and that is a third of the size of CD, well then obviously CD must be 3A, mustn't it? And obviously same direction. So now I know that. MD, so M to A is a half B, but it's also a negative, and you see how I'm going the wrong way along that line, so it's negative a half B. Then the correct direction all the way up to D is A plus 3A, so that would be 4A plus 4A. So that's MD as a whole. Then I would choose either MN or ND. I think let's go with M to N. So MN, let's see. You've got 2 options. We can either go along to B and then up to N, or we can go along to A, up to C and then down. That's kind of up to you. I feel like I might actually go the longer way just because of the way they've written these vectors. You see how they've gone in the direction of C to N and C to B? It's in this direction, isn't it? So I might actually follow that. So we've got obviously the same minus a half B because we're going from M to A. Then up to C is just plus A, so that's fine. And then C to N is a small part of C to B. So actually, if I come over here, I need to know CB first. So C to B, I would go down to A and then along to B. So we've got minus A plus B. And then C to N is just a smaller part of that, isn't it? So I want to use the K that they've given me in this question. K is obviously our scale. So I'm going to put plus, because I'm going the correct direction. K multiplied by the whole of CB, isn't it? That's literally what they've said here. So that's my vector for MN. Now that I've got 2 vectors from that supposed straight line, the second one is a bit more complicated, so I'm going to expand it and collect all the like terms. What I mean by that is get all the A's together and all the B's together. So it's just a bit of rearranging now. So expand any brackets that you have. So here we would have minus KA plus KB. And then I want to get the A's together and the B's together, but you might have obviously noticed that some of them have numbers and some of them have letters. Numbers and letters are not like terms. I can't literally add or subtract them. So what I'm going to do in this case is use factorizing. So let's do the B's first. We've got minus a half B plus KB. So what I can do with that is literally write it as K minus a half. I'm putting the K first just so that the negative is second. It doesn't really matter. And then B. So do you see how that's been factorized, the B being the common factor? And now this part here is my coefficient, is technically a number, isn't it? Because K, I know, represents a number. And then do the same for A. So we've got, I know you can't see it, but that's technically a 1A, isn't it? Minus K. So plus 1 minus K, A. And again, 1 minus K is the coefficient of A. So once you've done that, you've got everything in terms of something A, something B. You're going to want to compare those 2 vectors. And more specifically, we want to compare the coefficients. So looking at B's, for MD it's minus a half as an actual number, and then for MN it's K minus a half. We want to solve something to find K. But this is the bit where it can get a bit tricky. You might be happy up to this point and just stick with these marks that you'll get for writing down these vectors. This is the bit where it feels like it goes a bit left field. So let me just move CB out of the way. Just going to put that there so we've got some space. What we need to do is create 2 equations, one for the coefficients of B, one for the coefficients of A. Now, we can't put them equal to each other because obviously if you actually look, MD is not the same length as MN, is it? Clearly, one is a smaller version of the other. There's obviously a kind of scale there. Now, we don't care about the scale of this straight line, but we do technically mathematically need to use it. So I'm going to write an equation. You can choose whatever letter you want, obviously not K because you've already got K. I tend to use X. Let's just imagine that X is the scale between MD and MN. I don't care what X is, I actually don't need to find out what it is, but I do need it to be mathematically correct. So making an equation for the coefficients of B, I can write that minus a half is the same thing, or is equal to, X, so my scale, times by the coefficient of the other one, so K minus a half. So that's my B equation. Now I'll do this exact same for A. So we've got 4, and then we've got 1 minus K. Now again, they're not exactly equal, but they've been affected by this scale. Now it's the same scale because they are parallel lines, aren't they? So I can write 4 equals the same one, which is X, 1 minus K. Okay, so that's my equation for the coefficients of A. These are basically simultaneous equations, aren't they? Because I've got X and K that I don't know. Now, I actually don't care what X is, so I'm not going to find it out, but I want to find out what K is. So now you're going to deal with these like they're simultaneous equations, but we're just trying to find K. So when you're thinking about simultaneous equations, you have to get rid of one of the letters first, don't you, to find the other one. So I'm going to get rid of the X in order to then just be left with a K. So I'm going to rub all this out, just to give me more space, and then we'll work it out. Okay, so these are the exact same simultaneous equations, I've just moved them over to get a bit of space. There are many ways to solve these are linear simultaneous equations. The way I'm going to solve them is that they both have X in them. So what I would personally do is just make X the subject of both equations, and then make them equal to each other. So for example, here would be minus a half over K minus a half equals X, and this one would just be 4 over 1 minus K is equal to X. Now X is the same thing, isn't it? So I can make those two equal to each other. So minus a half over K minus a half is the same thing as 4 over 1 minus K. Do you see how now I've got an equation with only K in it? Because K is the only thing I want. You can find out what X is if you want, but I don't need it. I don't care what it is. Now we're just solving equations. So because we've got two fractions, I'm going to cross multiply like this, so that I can obviously get rid of the fractions. So we've got minus a half times by 1 minus K on one side, and then 4 times by K minus a half on the other. Obviously at this point we're going to expand. So I get minus a half plus a half K equals 4K minus, technically that's 4 over 2, which is just 2, like a half times 4 is 2, isn't it? Okay, now let's get all the K's together. So I'm going to move the half K. So subtract that, we get 3.5K, and then add the 2. So minus a half, add 2 is 1.5, isn't it? Then finally, we just need to divide by 3.5. So we get, I'm going to leave it as a fraction because it's not a nice decimal. K is 3 over 7. So what we're saying is that Cn is 3/7 the size of Cb. That's your answer. Now let's just try the final question where you can see, hopefully you might be able to start to see that there is a pattern in these two methods, that we've done basically the same thing. Okay, so the last one we've got ABC is a triangle. M is the midpoint of BC. Let's fill in our vectors. So A to B is A to C is B. Then they've told us that AX to XM is 4 to 1. Now this is not a vector, this is just a scale, okay? So those aren't vectors, they're just numbers for the scale. And finally, we want to work out the ratio AN to NC. So it's not the same as the last one in terms of asking for K, but a ratio and a scale is effectively the same idea, isn't it? Now they've mentioned specifically the line AXM, so that's the one I'm going to use. So I want to find, again, two vectors from that line. The easiest one I think is the whole thing, so A to M, let's start with that. We've got two ways to get there, haven't we? But either way, I'm going to need to know BC. So first of all, let's do BC. B to C would be minus A plus B. And then because M is the midpoint, so let's say I start at A, I'm going to go along to B. So A to M, I go along to B, so that's a positive A, because I'm going the correct direction. Then BC, I'm also going the correct direction, so plus, but I'm only going halfway. So I can put half minus A plus B. Okay, so that's A to M, that's one of my vectors. Now at this point you might want to expand it, simplify it, collect the like terms and so on. So that would be A minus a half A plus B, which obviously then I can add these two together is just a half A plus B, isn't it? So let me redo that. 1/2 A plus 1/2 b. Okay, so now I'm going to use that to find 2 of this line here, bxn. So let's say b to n. That one's going to be minus a plus, now it looks like the midpoint, but it's not because they've asked us to find that out. We don't know how far up that is, do we? We don't know the scale, so let's use k in this case. K of AC. Now AC is just b, isn't it? So kb. Okay, now let's find a second vector from that line. So either bx or xn. I'm going to go with bx. So b to x, I'm going to go again to a, so minus a, and then part of am. So that's why we needed am. Plus, because we're going the correct direction, now I can use this ratio 4 to 1. So as a fraction, 4 to 1 is, the 4 side is 4/5, isn't it? Of am, which was 1/2 a plus 1/2 b. Okay, now that one I'm obviously going to have to now expand and simplify. So minus a plus, that would give me 4/10, wouldn't it? So I'm going to simplify that to 2/5. A plus, again, 2/5 b, which if I add that together, so I've got minus a plus 2/5 a, gives me minus 3/5 a. So let's rewrite that. So we've got bn here, and then we've got bx here. So those are our 2 vectors that we're going to compare. So let's compare our coefficients. So we've got here, technically that's -1, isn't it? -1, now that's the bigger line, is equal to, obviously there's some kind of scale on this line bxn. Again, I don't care what that scale is, but I do technically need to account for it. So let's call it x, is our scale factor, is equal to minus 3/5 times x. Minus 3/5. Or let's just rewrite that as minus 3/5 x, yeah? So that's our equation for the A coefficients. Now for the B ones, here we have just k, and then here we have 2/5. Again, they're not equal to each other, but we've got this other scale factor applied. So what k is equal to 2/5 of x. Again, I keep repeating it, but I don't care what x is, I just technically need it there mathematically for this to make sense. So now that I've got my simultaneous equations, again, I'm just going to solve it, as you can see, to find k, because that's the one that's actually relating to my line ANC. Okay, so we've got our 2 equations here. Again, I want to eliminate x in order to be left with just k. So I think I'll do the same as I did with the previous one and just get x as my subject. You might find a different way to do it, that's absolutely fine. So -1 divided by minus 3/5 swaps it to 5/3 positive. Okay, well, technically in this case we've solved what x is, but that's fine. In that case, seeing as we've solved it, we might as well just sub that straight in, mightn't we? So k is equal to 2/5 of x, which is 5/3. So 2/5 times 5/3 gives me, as a fraction, so k is 2/3. As you can see, that just cancels out the 5s, doesn't it? Now, the only thing left is that we want it as a ratio, not as just a scale factor like the previous question. So if we remember what we had as k was referring to a to n, wasn't it? So that's 2/3. Therefore, the other part of that line must be 1/3. So if we look at that, an to nc, we need to know how to convert from a ratio into a fraction, but also a fraction back into a ratio. Basically, we just look at the numerators, don't we? So that's 2 to 1. Okay, so that's your answer for this one. But hopefully you can kind of see that there's a pattern between both of these questions. We have to figure out, first of all, a load of different vectors, but specifically 2 vectors from the same line. Then we compare the coefficients and create simultaneous equations, and then we solve the equations. So thanks for watching this video on the final part of vectors geometry. If you want to go back and check out any of the other videos, they will be linked down below. If you found this video helpful, make sure to like and subscribe, and leave down below any questions or comments that you might have.